What is Free Pascal? It's an open source project of the programming language Pascal. Pascal is the best language that teaches you how to program for all operating systems like Mac, Linux, Windows and the Internet. I don't want to annoy you with a repetition of ancient details, so I'll just talk about the important steps in the history. Let's see the steps already done and our plans for Pascal and especially Lazarus and FPC. To begin with, we are convinced that the Internet will become the absolute creating and communicating factor for our future, ChatGPT or not. The Internet will be, or even is, the horizon for all of us. So we concentrate on the Internet in our future goals. Free Pascal is an environment for developing software on whatever OS and the Internet. It is an open source Pascal compiler, and we try to let it be the best. Let's go back. In 1995, Borland announced that the DOS development for Borland, so-called Turbo Pascal, would stop with version 7. Borland came up with a Windows-only product, which later was known as Delphi, and it became the successor of the Turbo Pascal. Believe it or not, this has actually caused the creation of Free Pascal. Florian Paul Klemfel started working on his own compiler in the Turbo Pascal dialect. He created 32-bit code for the DOS extender. That was in 1989. It was a software development suite for IBM PC compatibles who supported the DOS operating system. The first version of the compiler was a by Borland Turbo Pascal compiled 16-bit DOS executable. The compiler then was able to self-compile and was actually a 32-bit executable. Now just at that time, the first contributors joined the project. Michael van Kanuyt started and he later produced a Linux port. This was even 5 years before the Borland Kylix compiler for Linux was released. Version 1 of FPC was launched in July 2000, and after that the preparations for a first release started. The version 1 was widely used in businesses and education. The 86K CPU port was rewritten and the compiler generated stable code. The compiler ran on a number of Amiga and Unix-like operating systems. Free Pascal has now arrived at version 3.22 and soon will be updated. So far the creation of Free Pascal. Before Lazarus started, the first trial project, Megiddo, began in what now is already another century, 1998, but ended somewhere a year later in 1999. The Megiddo project was a historic attempt to develop an IDE and integrated development environment for so-called Rapid Application, short RAD, with the Free Pascal compiler. But it did not work out that well. The company crashed. While the project failed, it unfolded a lasting impact, because it facilitated the transition from Sybil to OpenSybil. Even more important is the fact that it laid the foundations for the development of Lazarus. Now 3 individuals, Cliff Baseman, Shane Miller and Michael A. Hess, began Lazarus in February 1999. Each of these 3 had tried to get involved with the Megiddo project but did not succeed. Therefore, they finally started their own project, Lazarus, out of frustration with their earlier Megiddo experience. Lazarus is an IDE, some sort of integrated software environment, as mentioned before, built in a way that it is very flexible and extensible. And of course, it's open source. Lazarus can be used with all kinds of OSs. It allows execution of one and the same codebase. That makes it an IDE which is adaptable now for the future. It can be used everywhere. And for native coding, which is unique. It feels similar to Delphi, and it can be used to create console and graphical applications, Windows services, daemons. It works with native coding, web applications and WebAssembly programs. Lazarus FPC works on the inheritable object principle. It has an object inspector that will support CSS, and of course it also supports code completion in the process. It has a cross-platform user interface framework. This is called the Lazarus Component Library, short LCL. It will get a cross-platform graphical user interface framework called Fresnel, including all standard components, which can be used by the Skia open source graphical library. Fresnel will be explicitly targeted at the end of this video and is a project under development. Graphical applications created with the LCL can be ported to another platform through recompiling or cross-compiling. For making these cross-compilations, FPC Deluxe is a very smart installer and helper for cross-compiling, nowadays maintained and constantly updated by Alfred Glanzer, alias Long Dirty Animal Alf. It does not only install it all, but makes cross-compiling for various platforms easy to do. The next member to join was Mark Woising. He got involved with the project in August 1999. Mark was looking for a Linux Delphi. At that time Borland had not yet developed Kylix, and he was also interested in Linux in general. He joined the Lazarus project because of that. It had some hard-coded GTK menu items. GTK is a free and open source cross-platform widget toolkit for creating graphical user interfaces. Mark is still a core contributor. He's a member of the Free Pascal and Lazarus Foundation. A year after this, Matthias Gertner joined. That was in September 2000. And with Matthias as a member of the team, the project made a significant move forward. Matthias ported SynEdit and coded large parts of the coder tool and the designer. With these new additions, Lazarus began to look more like it does today. 3 years later, Matthias added the package system, and he has to add further IDE features and enhancement. Martin Friebe joined the team and started his contributions to Lazarus by cleaning up and refactoring the SynEdit coder. He has since added many new features such as SynchroEdit. Later he added multi-window views to the source editor and greatly improved the debugger. And now the debugger is really functional. Matthias and Martin helped writing the Lazarus handbook and created quite some explaining chapters. The main author was Michael van Kanait. It was his second book about Lazarus. The book is now being translated into German and will be updated in the following period. Past2JS was created by Matthias Gertner and Michael van Kanait. Past2JS is an open source Pascal to JavaScript transpiler. It parses Object Pascal and emits JavaScript. The work started in 2005 after learning of the Morphic project. It had a similar aim. The work resumed in 2015 and the first workable version was released in 2018. The JavaScript is currently of level ECMAScript 5 and should run in any browser or in Node.js. It's available in 5 forms: a library, a command line program, a web server, a Node.js program, and a program running in a browser. It transposes from actual Pascal source. It has no intermediate PPU files. That means all sources must always be available. The compiler can use JavaScript classes through external class definitions. All classes available in the JavaScript runtime and in the browser are available through import units. This is comparable to the Windows or Unix for the native compiler. For Node.js, there is basic support for the Node.js runtime environment available, and an import unit for jQuery is available. libjQuery it's called. As a non-commercial open source project, we are always searching for helping hands, so if you want to lend a helping hand, https wiki freepascal org Past2JS how to contribute. The website of the FPC Lazarus Foundation is being rewritten in Past2JS and will be the working example of an in Pascal coded website compiled with WebAssembly and Past2JS. We have 2 extras added to serve our community even more. Visual Studio Code is now supported by Lazarus. The explanatory article is published in the Blazed Pascal magazine. Second, Delphi code can be handled by Lazarus and can be recompiled with the Delphi compiler. This means you can code in Delphi, open your code in Lazarus, and alter the things you want to change. You can now work under Linux, but also compile for Linux, or do the same for the Mac. Once done, you can recompile all of it with the Delphi compiler. 1. WebAssembly for FreePascal and Past2JS. WebAssembly, WASM, is a binary instruction format for a stack-based virtual machine. That means a stack machine is a virtual machine in which the primary interaction is moving short-lived temporary values to and from a push-down stack. WASM is designed as a portable compilation target for programming languages. It enables deployment on the web for client and server applications. WebAssembly is designed to maintain the versionless, feature-tested, and backwards compatible nature of the web. WebAssembly modules will be able to call into and out of the JavaScript context and access browser functionality through the same web APIs accessible from JavaScript. WebAssembly also supports non-web embeddings. You can define the portable binary format to serve as a compilation target. This can be compiled to execute at native speed by taking advantage of common hardware capabilities available on a wide range of platforms, including mobile or IoT. I'm going to mention some additional features. It is initially focused on key features like threads, multiple data stream. It designs to execute within and integrate with the existing web platform. It also executes and combines with JavaScript. And now it allows synchronous calls to and from JavaScript. You also have access to browser functionality through the web APIs accessible to JavaScript, so you can define a human editable text format convertible to and from the binary format and designed to support non-browser embeddings as well. The next point. Artificial intelligence. TensorFlow is a free and open source software library for machine learning and artificial intelligence. It can be used across a range of tasks, but has a particular focus on training and inference of deep neural networks. It will also be of help in the project for Pascal Learning. The Lazarus PDF Kit is an ongoing project for our Lazarus programming. It originated from a text search engine, finding a text in PDF files. Because of the search capabilities, it will be used in the help file, F1, in Lazarus. It will gradually be extended with all the needed functions one has in a PDF, and Michael puts extra efforts into it to create maximum qualities, so we will finally have a PDF kit that has very high standards, especially for the graphical display. It will be usable on all platforms and free, available for any user. We choose the name Lazarus PDF Kit. The Lazarus Learning Project is a project for Lazarus for beginners and for kids. Now about Fresnel. Fresnel is a visual component library. It is based on CSS and custom-drawn components. It is in an early stage of development, but we have a first proof of concept. It is an alternative for the LCL, and that is capable to have pluggable rendering engines like Skia. Skia is an open source 2D graphics library. It provides common APIs who work across a variety of hardware and software platforms. It serves as the graphics engine for Google Chrome, Chrome OS and Android. And it is a replacement for the LCL, the Lazarus Component Library. The LCL, its Delphi counterpart VCL, is old. The foundations of this UI framework were laid 20 years ago when it was conceived as a free version of the VCL, which is the framework used in Delphi. Its design reflects the Windows User Interface Toolkit, Windows 95, the Windows 32 API available for the first time in Windows 95. You could say that the LCL is a 7-year-old technology. You can take 20-year-old code and still create a working application today, thanks to the great efforts to keep things backwards compatible. Very important. The user interface development in the browser is based on two standards: HTML, the DOM, and CSS. CSS offers a lot of possibilities in terms of user interface customization, and the possibilities of CSS still grow. In response to these new platforms, FireMonkey was introduced in Delphi, an alternative to the VCL which can be used on multiple platforms. It has styles which can be used to accommodate for the various form factors and can be seen as a replacement for CSS. FireMonkey can handle different backends. For example, Skia can be used as a backend for OpenGL. But at its core, FireMonkey still uses the positioning pattern used in the VCL, and the styles mechanism uses a format of resembling the DFM format. Instead of introducing a new format to update the user interface layer of Lazarus, it is a logical choice to reuse a successful and standardized mechanism, CSS. The paradigms of the VCL must be completely thrown overboard. And that means no more obligatory positioning, no more properties like top, left, width and height. Instead, all matters for the UI, user interface, and layout must be delegated to CSS properties. In short, the aim of Project Fresnel is to make a set of controls or widgets which are guided by CSS. These controls obey the following architectural principles. The widgets must be streamable. That means the widgets are descendants of the component and must use published properties. This requirement means a form file can be made, and the Lazarus IDE can be used to manipulate the widgets. The layout and looks are determined completely by CSS. This means every widget has a property which represents the CSS to be used. This means every widget has a property which represents the CSS to be used. Additional properties for manipulation in an object inspector can of course be introduced. Multiple drawing backends must be supported. Since Lazarus is multi-platform, it goes without saying that the various platforms will provide a specialized backend, much as the custom-drawn widget set of the FPGA-based widget set offers today. The FPGA means Free Pascal User Interface. The widgets will be independent of this LCL. No dependency on the LCL must exist. The widgets must be able to coexist together with an LCL framework. An application must be able to handle LCL forms together with CSS-based forms. In effect, the LCL will provide one of the possible backends for the Fresnel widgets. Ideally, a project made with Fresnel widgets should be able to take an existing CSS framework, such as Bootstrap, Foundation or Tailwind CSS, and apply it to a form. That means we need to provide several things: a CSS parser and a mechanism to translate the CSS to native structures, a CSS resolver mechanism. This mechanism determines what the CSS rules apply to a given widget, a drawing mechanism that knows all supported CSS properties, and a layouter. CSS has several means to determine the layout: float, flex, grid, etc., as determined by the display CSS property. Some widgets that mimic the standard HTML elements. The CSS framework assumes the existence of certain tag names like div, span, p, label, etc. So we need to provide widgets that react to these names. The work on this has been started. A CSS parser and resolver have been created already. A drawing backend based on the LCL has been started and the first layouter has been written. A CSS rule can select elements based on tag names, elements, IDs, pseudo-attributes and tag hierarchies. For object IDs, it seems natural to use the component name as the attribute. This removes the need for the HTML equivalent of getElementById, since every element will be a component defined in the form. A tag hierarchy maps naturally on a parent-child relation such as it exists in the VCL or LCL. The mapping between tag names and attributes has been abstracted in an interface. It is up to the widget what tags and attributes it reports to the CSS engine. Project Frusnel is a large project to rejuvenate the user interface possibilities of Pascal. The project has been started already and the first results have been obtained. A proof of concept using the LCL as a backend has been created. The code can be found at Git repository on GitLab.